All right. How the heck does this work? Hi, I'm live here. Just trying to figure out how to get this darn meeting started. Good.
Here's Rory's.
Yeah, perfect. Thanks. I'll
Yeah.
see you in a little bit.
Yeah.
Oh, I need to start a meeting. All right. What is going on here? Okay. All right. Sorry, gang. I need a minute. I'm trying to get this all set up, and I don't know how. So, let's see. I don't know what's going on here. There we go. Okay, so we're going to try this a little different this morning. We're going to attempt to do live video as well as run a meeting here. Okay. All right, so no camera is available. Well, that's not going to work. Jeepers. Okay. There. All right. Okay, so if you're on here right now, try joining that meeting, and let's see if we can get this to work. This is going to be a struggle, but I'm going to try it this way this morning. If I don't like it, then we'll just I'll do the full presentation live on YouTube, and then we'll meet up after. But you can join that meeting. Okay, sorry. It's taking me a little bit to go here. Okay, so today we're looking at linear relations. So a linear relation just means a relationship between two variables, and the two variables have a, they'll end up being a line. You'll see that the x and the y's will have a slope to them, and they'll have a relationship between the y and the x. Okay, so the best example I can use for you is, let's say, and then there's a, sorry, I'm all flustered here. There's a number of ways in which we can do this. So I'm going to start this way. First thing I'm going to do is I'm going to put it in words. Okay, so the first thing we can say is, all right, Jim works at the co-op. He gets paid $10 per hour plus a $20 tip at the end of the day, at the end of his shift. Okay, so the first thing I can do is I can write out this, like I've done, I can write it out in words. So Jim works at the co-op, he gets $10 per hour plus a $20 tip at the end of his shift, or at the end of the day. And what I would do is create a table of values. So there's words, equations, table of values, graphing, and so on. So I'm going to create a table of values for this. So to the best of our ability, we'll write it out. So let's say he works for 0 hours. Okay, he works for 0 hours. So X is going to be hours work, and Y is going to be his income. Okay, morning, Emma.
Morning.
All right, so if he were just to show up at work and he gets told to go home, let's say he makes his $20 tip, because that's still the end of his shift. All right. If he works for 1 hour, he gets $10 for the hour he worked plus a $20 tip, $30. Okay? If he works for 2 hours, $40. 3 hours, $50, and 4 hours, $60. Okay? So I've created a table of values from the words that I've been following here, in which he gets paid $10 an hour plus a $20 tip. So the first two ways in which we can write out a linear relation is using a table of values or using words. The third way in which we can do this, all right, is write out a set of ordered pairs. I'm just going to shrink this for a second. I'll make it bigger. So an ordered pair is the X and the Y values from your table of values rewritten as an ordered pair as to how we would graph them on a Cartesian plane or a grid. So I'd have 0, 20, 1, 30, 2, 40, 3, 50, and 4, 60. Okay, so those values come from my table of values. Those are what we refer to as coordinates. Those are how we would graph them on a grid, which is where we're leading this discussion to. Okay, so I have that. So this is a, what do they write as? Ordered pairs. These are ordered pairs. So this is the third way in which we can write a statement about a relationship between an X and a Y value. All right. The fourth way to do this is to graph it. Again, we didn't talk much about this yesterday, or I didn't talk much about this yesterday, but the X, so this is the number of hours worked. This is what we refer to as our independent variable. It's the excuse me. It's the variable that changes. The y here is going to be our income or our pay in dollars. This is dependent on the number of hours worked. So the dependent variable is always your vertical. Your independent variable is always your x-axis. So now I've got 0, 1, 2, 3, 4, 5. I don't think I went up to 5. And along here, I'm going to have 0, 20, 30, 40, 50, 60, like that. Okay, and now I'm going to plot my coordinates or my ordered pairs. So I go to 0 and 20, start right there. Oops, my bad. Not a good start here to the day. Board's off. All right, let's try that again. 0, 20 is right here. 130, 240, 350, and 460. And I can draw a line up that way. So there is a graph to describe the relationship between the number of hours worked and the amount of money that he's going to earn as an income. Okay? Now the final and probably the most important thing that we're going to do is write this whole situation out as an equation. So the first thing I'm going to do is I'm going to define what my values are. So my x is hours worked. My y is the amount of pay or income that I take in. Y equals. All right. So my constant in this is 20. I know that I'm going to get $20 no matter what. This is what we refer to as our constant. X is going to represent the number of hours worked. Good morning. And to calculate how much I make, I take 10 and I times it by X. This we refer to as the slope of our equation. Okay, that's the coefficient. That's the value that's always in front of the x. So y equals 10x plus 20 describes as an equation in words what I've set up right here. He gets $10 per hour plus a $20 tip. Okay, so there's 5 ways in which I can explain a relationship, a linear relationship between the number of hours a person works. It says, consider the following 2 relations. Amir's height above the water after springing from a diving board, and the cost for downloading music from a site that charges $1.25 per song. For each relation, decide if it's linear or nonlinear, if it's discrete or continuous, what the dependent and independent variables are, and the best way to represent it in words, an equation, ordered pair, parent table, table of values, or a graph. Okay, so one of you has to mute if you're watching this on YouTube. Okay, so mute one or the other. Perfect. Thanks. This is going to work out. Okay, so somebody diving off a diving board. First thing I'm going to do is get a visual of it. All right, let's get a visual of what's happening here. So I've got a diving board right here. Person jumps up first and then comes down. Okay, so there's my visual of what's happening. This right here is going to represent the height above the water. And this will represent the time that you're at if you are jumping off the diving board and how much time it takes for you to hit the water. So when I look at this, you can't see it?
No.
Okay. Is it color or is it just not showing up well?
I think the board's just fuzzy in general.
Okay. Is that better?
Yeah, a little bit.
Okay. I'm wondering if I feel like there's a glare on it, but okay, we'll try it like this and see how it goes. Okay, so it says, well, the first thing we got to look at is if I was looking at this in terms of a graph now, I'm starting right here. I'm going up first and then down until I hit the water, right? So does that represent a linear relation between the time and the height? Well, is it a straight line? No. So this is not a linear relation. Can I describe it in words? Sure, I can describe it in words, but probably the best way to describe this is an actual graph. Okay, so it says Amir's height above the water is nonlinear. His height increases when he springs from the board and then decreases as he plunges. The data for this relationship is continuous. Okay, so the difference between discrete, I better write this out, discrete continuous is when you connect the dots, basically is what that means. It's a solid line. Something that's discrete is just plotting coordinates. Points or coordinates. Okay? So discrete means that it's a broken graph. So it would be something like this if I were to go and not connect these points. That's what we would refer to as discrete. So continuous means that the line is connected all the way through. Discrete means you plot the points and you don't connect them. So it says, is it linear or nonlinear? It's nonlinear. It's continuous. What is the dependent and independent variables? What's the dependent variable here? The dependent variable is on the y-axis. What is it? Height. And the independent variable is time. So that's your independent. This is your dependent. Okay? And the best way to represent it, is it words, an equation, ordered pair, table of values, or graph? Well, right now with what we have, the graph is the best way to do it, but realistically, the best way to do this, or another way to do this is actually using an equation, but we'll wait till we get to grade 11 before we do equations of parabolas. Okay, and then the final one was the cost for downloading music from a site that charges $1.25 per song. Well, if I order 0 songs, let's make a table of values. 0 songs, $0. Doesn't cost me anything. I order 1 song, it's $1.25. 2 songs, $2.50. 3 songs, $3.75. 4 songs, $4. So what I've created is a table of values here. If I were to plot that table of values, the number of songs is my independent variable. The dependent variable is the cost right here. And it would look something like this. Now, Can I have a portion of a song? Can I buy a portion of a song? The answer is no. So I can't actually connect this line here. Okay, I can't connect that line. So to answer the questions, is it linear or nonlinear? It's linear, all right, because it would create a straight line. Is it discrete or continuous? It's discrete. Because I can't have fractions, I can't connect these dots. So it's not a continuous relationship. What's the dependent variable? The cost is dependent on how many songs you buy. So that's the independent variable. And the best way to represent it would be a table of values, ordered pair, or a graph in this case. Okay? So I just want to have a look here, girls. And the graph's a little harder to see, right? Okay. All right. So that's basically all I have for today on 6.2. Did you girls that are on here right now, I'm just going to see if it's just the three of you. Oh, Emma is also on there. Perfect. Hi. Oh, Emma. Okay. So how did you girls make out yesterday on the work? Any questions? No? Okay. So we'll do 6.2 today. I had initially said that I was going to schedule a meeting for at the end of this. Anyways, what we'll do, I can't do it without starting the meeting on the internet. Okay. So if you have no questions, I will check in with you at about probably 9:50. Does that sound okay? Sure. Okay. We'll talk in a bit then, girls. Okay, bye.